What mass of steam at 100 degrees C must be mixed with 150 grams of ice at its melting point in a thermally insulated container to produce liquid water at 50 degrees C? There are two types of the substance in the systems. One is the steam, another one is the ice. For the steams, the initial temperature is 100 degrees C. And for the ice, the initial temperature is 0 degrees C, which is the melting point for the ice. These two substances will exchange the heat. Since the initial temperature for the steam is higher than the initial temperature of the ice, that means the steam will release the heat and the heat will be absorbed by the ice. The exchange of the heat only happens between these two substances. There is no heat loss to the surrounding because the question said the container is insulated. As a result of the heat exchange, finally, the temperature of the system is 50 degrees C. This is the temperature after the systems attain the equilibrium, and the state is the liquid water. Our aims is to find what is the mass of the steams that require to melt the 150 grams of the ice completely and then rise its temperature to 50 degrees C. So that means we want to find what is the mass of the steam required, and we denote this mass of the steam as the ms. And the mass of the ice, which is 150 gram, is we denote it as the mi. The key is that the amount of the heat gained by the ice is equal to the quantities of the heat lost by the steam. The initial temperature for the ice is 0 degrees C, means it is at its melting point. So once the ice absorbs the heat from the steams, it will start to melt. The heat required to completely melt the 150 grams of the ice is equal to MILF. After the ice is completely melted, the temperature of the water produced will rise to 50 degrees C. So we denote this 50 degrees C as a TF. That means the heat required to increase the temperature of the produced water from the 0 degrees C to 50 degrees C is equal to MICW T final minus 0. This is the temperature change. CW is the specific heat capacity for the water. This LF is the specific latent heat for fusions for the ice. So we sum up these two terms, we will get the total heat absorbed by the ice. The mass of the steams that contribute the heat to the ice, as mentioned just now, it is denoted as ms. So these portions of the steams, after it loses the heat, it will condense. So the heat released due to the condensations is the MSLV. LV is a specific latent heat for vaporizations. So the value is the same as the heat released when it is undergoes the process of the condensations. So we have MSLV. And these terms means that the heat release of the water at the 100 degrees C that produced from due to the condensations. Since this part of the water will reduce its temperature from 100 degrees C to the 50 degrees C, so this one is the total amount of the heat release when the temperature drop from 100 degrees C to 50 degrees C. Cw again is the specific heat capacity for the water, and this ms is the mass of the water produced from the steams after the condensations. So these two quantity at the right hand side and the left hand side of the equality sign should be equal. That means the heat gain equal to heat loss. Now we expand the second terms at the left hand side and the second terms at the right hand side. So we will have two terms at the left hand side. Because this is a 0, then we will have the second term is MICW times the TF. Again, TF is a 50 degrees C. And for the right hand side, after we expand these second terms, we will get two terms. So in total, three terms at the right hand side of the equality sign, where this one is 100 MSCW minus MSCW TF. We factorize the MI at the left hand side of the equality sign, and also we factorize the MS at the right hand side of the equality sign. Bear in mind that our aims is to find the value of the MS. So now we change the MS as a subject of the equations. That means now we will bring this bracket to the left hand side, and it will becomes the denominator in these expressions. Now we can start to substitute the value. For the MI, the mass of the ice is 150 gram. LF is a specific latent heat of fusions for the ice. It is 3.33 times 10 to the power 5. CW is a specific heat capacity for the water. It is 4,186. T final is 50. LV is a specific latent heat for vaporizations. It is 22.6 times 10 to the power 5 joule per kg. Again, the CW and CW, these two values are the same. And this is also CW, and TF is 50 again. So finally, we obtain the MS. The mass of the steam is 0.033 kg or 33 gram. This is the quantity of the mass of the steams that melt the 150 grams of the ice and increase the temperature of the water produced from the ice to 50 degrees C. At the same time, because this 33 grams of the steams loses the heat, it will condense and then becomes the water, and its temperature also will drop to 50 degrees C. So this is the mass. We say that this is the mass of the steams that require to melt the 150 grams of the ice and to produce the liquid water at 50 degrees C.